Well, good morning again. Good afternoon, good evening, whatever it is, wherever you are. And welcome back to my little science lab. Before I get started with this video, I just want to say that the likelihood of me remembering every aspect of this general unifying theory or solution to all other predicaments with known theories. Um, I'm not going to be able to get it all out in one video. I was trying to write myself some little notes here to explain, but this theory, if you will, um, sort of interpretation of my instincts, really, um, is meant to explain electronic and subatomic resonance, molecular or atomic radiation, why radiation is possible, why the bigger the atom, or why different numbers of uh, um, forces, let's just call them at this point, um, you think of them as particles. I'm here to tell you they're not particles, according to this theory, if this theory is correct. Have lives, um, electromagnetism, uh, the the black effect, or whatever it's called. Um, and this should also cause what would wind up being perceived, at least mathematically, as a basically an explanation for why you'd perceive relativity to be an effect on space and time because of what's been observed in quantum mechanics. Now, quantum mechanics I find fascinating because people did some experiments that helped a lot of things. Okay, don't get me wrong. The quantization of energy in general, the quantization of electromagnetism, was obviously very beneficial. You know, I enjoy it. But the thing is, it doesn't necessarily, according to this theory now, if this theory is right, it should be very, very, very helpful. If it's wrong, fuck it, I apologize. But this shit makes sense to me the more different things I apply it to. But basically, there are no particles. There is only, essentially, causality. Basically, force. The force, if you will. Sorry, I'm feeling fluish and my hand's a little bit shaky. I apologize for that. If you haven't figured it out yet, these are, guess what, atomic models. And let's just say, after I drew this one, I really started to question whether or not this part is even necessary. Because this is sort of an illusion created by resonance. It's not really a nucleus at all. And while quantization as a theory is correct, I think it missed the mark, or the periodic table missed the mark by half. Because if it was correct, or I think if it was correct, then the inner valence 2 electrons would turn out to be a quarter of a photon each. And that just doesn't seem right with the whole quantization principle. But anyway. So, being that this is a sketchbook, these are 2-dimensional representations of what obviously is a sphere. And these waveforms say, for instance, this would be a mathematical subdivision in infinite flux. And the reason why I say it's causality as opposed to some magic dispersal of particles, and I say magic because to say something just appears and reappears somewhere else instantly, it seems to me that you've failed to find the solution. However, if you let go of the particulate nature of some atomic forces, you are left with a clear solution to both the quantum uncertainty principle and the quantum entanglement principle. And to solve the quantum uncertainty principle, let me just demonstrate, for instance. Let me just actually demonstrate exactly the solution that supposed particles as actual waveforms would solve. You see, quantum uncertainty would be this easy to solve. What I'm implying is that your eye is the grounding point. When you observe something, you're basically absorbing it electrically, the same way a computer absorbs data through a USB port. Picture that. You're not just seeing light. You're taking it in right now. It's a wonder your eyes don't overheat. I suppose that's why. It's good to have reflective material right there. It's good to have white around your eyes right there. It needs to stay cool. It needs to focus light where it needs it and reflect it the rest of the way. Keep it from absorbing infrared. But when you see light coming from, say, what is this? A glowing piece of rust on a pan. Because that can't be iron or carbon, so. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. Eight electronic waves 8 positive waves. Now the thing is, this contradicts the Bohr model. I understand the modern models that you have, but you see, when you have waves in a spherical pattern, or even in a circular pattern, you wind up with areas of resonance. And when it comes to perceiving where an electron is, you have areas where that resonance is most likely to occur, and that's where you're most likely to see the electron. Now, obviously, the closer you get to the positive end of the electromagnetic force at play here, and that's all this is, it's just electromagnetism. An atom is just energy. It's not particles, it's just energy vibrating in a sphere. This is a very simplified two-dimensional rendering. But you can see how, for instance, light can reflect off of something. That's what this mostly shows. But it also shows how electromagnetism inputted can resonate off of the electromagnetism that's already resonating and vibrating, or what's being perceived as vibrating particles, or a vibrating particle. It's just a bunch of energy forms resonating. Now, the smaller and more mathematically symmetrical, if you will, more geometric, the frequency, the higher the place on the periodic table. The higher the amplitude, the more neutrons in the isotope. So everything about this translates, including half-lives and radiation. So when you have an extreme number of different waveforms, no matter how symmetric each one of them is, when you have, say, a number like 97 of them for, was it Berkeleum? You're going to wind up with mathematical noise coming from the lack of multiples of factors, basically. So every time that resonance makes, basically, imagine an ocean, and there's waves going this way, and there's waves going that way, but every now and again there's that wave that claps upward. Well, that radiation is that wave that claps outward. So, hydrogen, helium, lithium, beryllium, Is that oxygen or carbon? That's oxygen. So, anyways, with quantum uncertainty, you had sort of a paradoxical scenario in which electrons were received in a resonant pattern unexpectedly when fired one at a time, as if they had been fired at the same time. And that's where physics breaks, basically. And that's where you start getting quantum mechanics. This experiment, I believe, was done to explain what happens when you put an electric charge through something and it lights up. How does it go from black to emitting all the different spectrums of light? Well, there's simple math that can be done here. And uncertainty is no longer required. And I wouldn't say simple math. If it was simple math, I wouldn't have fucked it up so horribly and be sitting here feeling like I need to reschool myself. But basically, you need to add vectors to spherical functions that basically overlap those vectors with other lines of resonance. And the basic principles of, for every action there's an equal opposite reaction is all this takes to work. So you're not seeing a particle coming towards you. You're getting electrocuted by a single atom. That's what a photon is. It's just transferring positive charge goes towards you, a negative charge goes towards it, or vice versa. I'm not sure. But I can just sense it happening. That's all. You see, we're all energy. I know I'm energy. If I wasn't energy, I couldn't do some of the shit that I've done. So when you think about it, every form of physical material is comprised of lightning. Everything. Every molecule, every thing of substance. That's why people who study quantum mechanics start thinking that reality is an illusion. Because if you don't add God into the equation and don't acknowledge that this is a force, it's originating somewhere. It's originating from the center of these things. It requires energy for them to exist. They're not sitting in a dormant state. Where's the energy coming from? It's an infinite resonance between existence and non-existence. And as that reality pulsates in and out of each one of these singularities, essentially, that's what every atom is. It forms a frequency. It has an amplitude, it has a frequency. It forms a wave. It has an amplitude, it has a frequency. The frequency determines the element, essentially. The number of perceivable electrons. And obviously, you can't have extreme isotopes of small elements. You would be able to if they were particles. You'd be able to quantify and measure the particles without using mathematical likelihoods to explain how you found them. But if it's a wave, then you just need a wave function, and to translate that wave function into spherical geometry. Similar to the way you would program one of those fancy magnetic fluid things that do all the dancing and stuff. Yeah. But when it comes to, say for instance, molecular cohesion, if you have the Bohr model, particles make sense. If you have the quantum model, basically, how do you get cohesion? If you have this resonance model, cohesion is obvious. Cohesion happens the same way this happens. These two waves merge and sustain each other. That's all this is just wave function dynamics. And like I said, everything is spiritual. Everything is an orb. Everything is essentially a conduit to the divine, masking itself in a vibration of illusion. So what does that make me?